The present does not exist. I don't mean that as poetry. I mean it literally. Physics does not give us a single shared now for the whole universe, even though your brain insists it does. You feel time like a film reel, one frame lit up, the rest dark. The frame you're in is real. The frames behind you happened and are gone. The frames ahead of you haven't happened yet, so they don't exist. That view is called presentism, and it is unbelievably convincing because it matches your experience. But experience is not a proof, it's a sensation. Here is the forensic question I want you to hold in your mind. If there really were one universal present, what physical process would keep the entire cosmos synchronized to it? What would enforce that distant events are happening at the same time in one absolute sense? Most people assume the answer is obvious. Of course there is a now, because it feels obvious. That is the invisible enemy in this case. Intuition masquerading as physics. In 1905, I wrote a paper that quietly detonated that intuition. The key result is simple to say and brutal to accept. Two events that are simultaneous for you do not have to be simultaneous for someone moving relative to you. Here's the cleanest way to see it. Picture a long train. Two lightning bolts strike the front and the back of the train. An observer standing on the platform exactly in the middle receives light from both strikes at the same moment. So they conclude simultaneous. Now place an observer inside the train, also sitting in the middle, but the train is moving. After the strikes, that observer moves towards the light from the front and away from the light from the back. So the light from the front reaches them first. After doing the correct bookkeeping for light travel time, the conclusion still stands. In the train's frame, the strikes were not simultaneous. One happened first. No one made a mistake. No one saw it wrong. The disagreement is built into space-time itself. And a crucial safety rail. Causality is not broken. If event A can influence event B, if a signal at or below the speed of light could travel between them, then every observer agrees on the order. What changes is simultaneity for events too far apart to be causally connected. So simultaneity depends on motion. And if simultaneity depends on motion, then a universal now is not a well-defined concept. The present didn't fade. It didn't move. It vanished as a universal object. That was the day the present disappeared, and almost nobody treated it like an emergency. So I'm going to treat it like one. I'm going to walk you through the evidence, the trap it creates, and the best suspects for where now might be hiding. Because if there is no single cosmic present, then the most dangerous question is not what time is it? It's what exactly are you calling right now? Relativity forces me to be precise about what now even means. Space and time are not two separate stages. They are one structure, space-time. When you say the present, you're really taking a slice through space-time, a cut that labels distant events as happening at the same time. But your slice depends on your motion. Change your velocity and your slice tilts. If you and I are at rest relative to each other, we can adopt the same slice and agree, by convention, on what is happening right now, far away. But if you move relative to me, your slice is angled differently. You don't just move through space. You change the set of distant events your frame calls simultaneous with this moment. A good way to picture the limit is a light cone, the region you can influence and the region that can influence you. Outside that cone, events are space-like separated. No causal message can connect them. And that is exactly where the present becomes slippery, because simultaneity there is not fixed by causality. Here's a concrete way to feel the weirdness. Imagine two distant supernovae explode in two different galaxies. In my frame, I might label them as happening at the same time. In your frame, moving relative to me, you might label one as happening first. Not because either of us is confused, but because the geometry of space-time doesn't give us one universal ruler for same time across space-like separation. At everyday distances, the tilt is microscopic, so you never notice. At cosmic distances, the same microscopic tilt becomes absurd. So try this. You take a casual walk, about 5 kilometers per hour, toward the Andromeda galaxy, roughly 2.5 million light-years away. Your walking speed is only about 5 billionths of the speed of light. That sounds like nothing. But multiply that tiny fraction by a distance measured in light-years, and you get time. The result is a shift of roughly 4 to 5 days. In your now, some distant events in Andromeda that I would label as a few days in the future become happening right now. And some events I call right now fall into your past. Let me be absolutely clear. You did not change Andromeda. You can't send information faster than light, and you can't exploit this to predict or affect anything there. These are space-like separated events, no causal link. What changed is the bookkeeping, the labels your frame places on distant, causally disconnected happenings. And this scales viciously. At 30 kilometers per second, faster than any airplane, slower than any science fiction ship, your speed is about 1/10,000th of light. Multiply that by 2.5 million years, and you get about 250 years. The present you assign to Andromeda can jump by centuries. Now the question that hurts. If your now and my now disagree about which distant events are present, which one is the real present? Relativity refuses to pick a winner. The principle is democratic. Inertial observers are equally valid. There is no privileged rest frame with the official cosmic timestamp. So the honest answer is, there is no universal present to be the real one. And once you accept that, a second question appears, like a clue you didn't recognize as a clue. If different observers have different nows, and all of them are valid, then what becomes of the future? Because for some observers, events you call not yet are already inside their present slice. That is how the block universe walks into the room. The block universe is the tempting suspect. If my now can cut through what you call the future, you might conclude that the future already exists, just like a distant galaxy exists, even if you will never visit it. In the block picture, past, present, and future are all equally real parts of one four-dimensional structure. Nothing flows. The universe simply is. Then what is the passage of time you feel? In the block story, it becomes a kind of spotlight. Only one slice feels illuminated, even though the whole structure exists. But a spotlight is an extra ingredient. Where does it come from? What physical law moves it? This is why the block universe is both seductive and suspicious. It's elegant. It also feels like an attack on your life. Because if the future is already a settled region of space-time, then your choices feel like theater. You experience decision, stay or leave, speak or stay silent, love or withdraw. But the block seems to say the script is already written. You are not authoring the next page. You are discovering a page that was always there. Here's the psychological sting. Regret becomes strange. Pride becomes strange. Responsibility becomes strange. If every outcome is already fixed, then what are you other than a witness to your own timeline? Now, watch the move people often make next. They treat no universal now as the cause, and the future is already written as the inevitable effect. But that is not a mathematical theorem. That is an interpretation. Relativity gives you different slices. It does not automatically tell you what ontological status to assign to the unseen parts of the structure. Block universe is a coherent way to talk about relativity, but it is not forced upon you. And then quantum mechanics arrives and complicates the simplest version of the block. Consider radioactive decay. A radioactive atom will decay, but standard quantum theory does not give you an exact decay timestamp that exists in advance and can be read off with perfect certainty. What it gives you are probabilities. You can say 50% chance within an hour, but not it will decay at 2:31. Does that mean the event is fundamentally random? Some interpretations say yes. Others say the underlying evolution is deterministic, but the price is high. Non-local hidden variables, branching worlds, or other conceptual costs. Experiments that test Bell's inequalities strongly constrain any local hidden variable story. Either way, quantum theory blocks the naive claim that the future is already a single set of definite facts in the same way the past is. At minimum, it says, the theory does not contain the kind of information you would need to treat the future as already settled in one unique way. And quantum events don't stay microscopic. Tiny differences can cascade upward, especially in chaotic systems, until which atom decayed when can influence chemistry, biology, and history. So, if parts of the future are not settled as definite facts, the detective question becomes, when do possibilities become a single recorded reality? Is that boundary what you mean by the present? If so, I may be able to recover now, but not as a universal sheet spread across the cosmos. As a frontier. So, here are the leading ways people try to make peace with all of this. Option 1. The growing block. The past exists as a fixed record. The future does not exist yet as definite facts. Reality grows as quantum possibilities become actual recorded outcomes. In that view, the present is not a cosmic sheet. It is the moving boundary where new history is added. Different observers may still disagree about distant simultaneity, but becoming happens locally along world lines. This idea is old, almost unfashionable, and yet it keeps returning because it fits the discomfort point. Relativity undermines a universal now, and quantum theory resists a single settled future. It is the kind of prediction that aged too well. Option 2. The local present. Maybe now was never meant to apply across the cosmos. Near you, where you can synchronize clocks and exchange signals, now is operationally meaningful. Far away, the question, what is happening right now over there, may simply have no single answer. And that is not a bug, it is the shape of space-time. Option 3. Many worlds. In that picture, quantum uncertainty doesn't leave the future blank, it makes many futures real. The underlying equations can be fully deterministic, yet the world branches into different consistent histories. Your future is not one line, it is a tree. The difficulty is that many worlds is often hard to distinguish experimentally from other interpretations that make the same predictions. Option 4. Emergent time. Perhaps time is not fundamental at all. Maybe now is something your brain constructs, like smooth motion from individual frames, or something that emerges from deeper physics involving information and correlations. None of these options is proven. Each solves one problem and creates another. That is the trade-off nobody likes to say out loud. And notice the irony. The success of modern physics created this problem. Relativity and quantum theory work. They predict the world with astonishing accuracy. And precisely because they work, they force us to confront questions our intuition was never built to handle. If you want a universal present, you tend to pay by adding extra structure that relativity doesn't naturally provide. If you want an open future, you must explain how that fits with relativistic slicing. If you want clean mathematics, you may pay with extravagant ontology, branching realities. If you dissolve time, you must explain why now feels so undeniable. So where does that leave you? It leaves you with two truths at once. Locally, along your own world line, before and after are real. You are between your birth and your death. Your memories point one way. Your records accumulate. Your choices matter to the people you can actually affect. Globally, across the universe, now is not a single thing. The present is not missing from your life. It is missing from the simplest story you were told about the universe. And finding the right story, that investigation is still underway. If this raised more questions than it answered, good. That means you're awake. And if you want the strangest consequence of relativity that quietly shapes modern technology every day, watch the next video.